Hello, we are still in section 11.2 series, and let us review this example. What should we do if we are asked to determine whether the series is convergent or divergent? The series. Here we first use the test for divergence. Try the test of divergence first. So for example, if you have this series tan inverse n, summation of tan inverse n from 1 to infinity. This is a series. Let us first check whether limit an is 0. If limit an is 0, then we can continue to check whether the series is divergent or convergent. It doesn't mean that the series is convergent. But if the limit of an is not 0, then immediately the series is divergent by test of divergence. So limit tan inverse n, as we know when n goes to infinity, is pi over 2. And that's not 0, so immediately the series is divergent by using the test of divergence. Now what about this series? Here, if you notice, we have sum of two series. The first one, this one, is a geometric series, 3 over 5n. You can write it in the form 3 times 1 over 5n, or you can 1 over 5 all to the power n. This is a geometric series, a times r to the power n. R here is 1 over 5 less than 1, so this series converges. But the second series is 2 over n. And 2 over n is just, you can write it 2 times 1 over n. And summation 1 over n is the harmonic series. And the harmonic series is divergent. So this series is divergent. So here we have sum of a divergent series and a convergent series. So this series would be divergent. So here we used the harmonic series. So we may use the test of divergence or the harmonic series. Or, this is the third possibility, and we have an example like this. This is again a geometric series. R is pi over 3, pi is 3.14, so R is greater than 1. So this is divergent because it's a geometric series and R is greater than 1. So these are three possibilities which we learned in this section. Now if the question is find the sum of each series, when he says find the sum, it means the series is already convergent, because if it is divergent, then it has no sum. It goes to infinity. So we know here that all the series in this question are convergent, and we need to find the sum of the series. Well, how can we find the sum? There are three cases in which are presented here in this section. The first case, if the nth partial sum is given. So this is the first question, the first example. The nth partial sum, Sn, is given. What is the nth partial sum? This is Sn. This is the sum of the first n terms of the series. If it has a formula like this, this is not an, differentiate between an and Sn. So this is not summation of this, the series. No, this is the nth partial sum. So if it has a formula like this, then by definition, the sum of the series would be the limit of Sn when n goes to infinity. And you can see that the limit of this is 1 over 4, so the sum of the series would be 1 over 4. So if you have a formula for Sn, it's easy to find the sum of the series immediately. What about if we don't have a formula for Sn? In this case, the series is given itself. This is an example. Find the sum of this series. then there are two possibilities. Either this series is geometric series and R is less than 1, so we can find the sum using the formula A over 1 minus R, or it is a telescoping sum, and we will talk about it in this lecture. So here, this is a geometric series, and to find out, just write the first few terms. So put N1, you get AE to the power over 3 to the power 0, which is 1, so the first term is E. The second term would be E square over 3. The third term would be E to the power 3 over 3 to the power 2, and so on. So it's a geometric series. The first term is E. And what is the common ratio? Divide this term by this term, you get E over 3. You notice we are multiplying each term by E over 3. So it's a geometric series with A equals E and R equals E1 over 3. R is less than 1 because E is 2.7 approximately. So R is less than 1. So this geometric series converges and the sum is given by the formula A over 1 minus R. Simplify this, you get 3E over 3 minus E. Now the last type would be a telescoping sum. What do we mean by this? We mean if AN, which is the sequence of terms of the series, is written in such ways, in similar forms like this. If you have in the denominator n times n plus 1, or n times n plus 2, or n minus 2 times n minus 1, see, there is a difference between these two. Here the difference is 1. Here the difference is 2. n minus 2, n minus 1. No, the difference is 1. But here the difference is 2. There is n plus 1 between them. Here the difference is even 3 because n minus 1, then n plus 1, then n plus 2. All of these are called telescoping sums. How? Let us see the meaning. What is important here, and we will be able to write, to find the formula for the nth partial sum using partial fraction. So for this series, we can find a formula for Sn, the nth partial sum. So it would be similar to the first example. Let us see how can we find a formula for Sn. This is an example. This is a series. You have n squared minus 1 here. If you factor this, it is n minus 1 times n plus 1. So n minus 1 times n plus 1, there is a 2 between them. There is a difference of 2. We can write Sn. Let us start writing Sn, the nth partial sum. What is the definition of this is the series. This is the nth partial sum. What is the definition of the nth partial sum? The sum of the first n terms, summation ai from 2 to n. Why we started from 2? Because the series is already starting from 2. Okay, so this is an. What would be ai? We replace n by I. So it would be 2 over I squared minus 1. Alright. Now we can use partial fraction to write this as a over I minus 1 plus b over I plus 1. And you can easily prove that a is 1 and b is negative 1. So this is the Sn. Sn, the nth partial sum, can be written in this form. Now let us try to expand this. Replace I by 2. What would you get? 1 over 2 minus 1 minus 1 over 2 plus 1. This is 1 minus 1 over 3 when I is 2. When I is 3, find, expand when I is 4, when I is 5, and so on. This is from the beginning. Let us also from the end. If you replace what would be the last term of this Sn when I is n? What would happen when I is n? It would be 1 over n minus 1 minus 1 over n plus 1. Let us write few terms before this term, and we will see why. Let us replace I by n minus 1. This is n minus 1. Go back one term. So put I n minus 1, it would be n minus 1 minus 1, n minus 2, n minus 1 plus 1, which is n. Write also the term when n minus 2 and when I equals n minus 3. Now look to these terms carefully. What do you notice? We have 1 over 3 here with minus sign and 1 over 3 here with positive sign. They cancel. We have minus 1 over 4 and plus 1 over 4. They cancel. And similarly, negative 1 over 5, there would be positive 1 over 5. They will cancel. So what would be left? We will left with two terms. They will not be cancelled. 1 plus 1 over 2. Because the difference here is 2. At the end, you will have two terms. 1 plus 1 over 2. Also here, you will notice that this term will not be cancelled. And this term would be cancelled. 1 over n minus 1 and 1 over n minus 1, they can cancel. Negative 1 over n, it will not be cancelled. But 1 over n minus 2 can be cancelled. So all of the terms will be cancelled except negative 1 over n and negative 1 over n plus 1. So Sn would be written in this form. So this is a formula for Sn. To find the sum of the series, just take the limit of Sn when n goes to infinity, and these would be zeros, and the sum would be 3 over 2. So the sum of this series is 3 over 2. The last example, it is applying also the telescoping sum. You have e to the power 1 over n minus e to the power 1n plus 1. Let us try to write Sn. Sn is summation ai from 1 to n. Now, how to find ai? This is an. Replace n by I. So you will have e to the power 1 over I minus e to the power 1 over I plus 1. Try to expand this. Write the first few terms and the last few terms. Put here the difference between them is 1. So it's easier than the previous one. So if you put I1, you will have e minus e half. If you put I2, you will have this one. You notice these two are cancelled, and this would be cancelled. And we will only, this term only will be remain from the beginning terms. From the end terms, you will notice that this would be cancelled and this would be cancelled. And e to the power 1 over n plus 1 would remain. So Sn is in fact can be written in this form. Now if you take the limit of Sn when n goes to infinity, this would be e to the power 1 over infinity, which is 0. So the limit of Sn would be e minus e to the power 0, which is 1. So the sum of the series would be e minus 1. Good luck.